Hi, my name is Dan Abbott. I teach at Southern Maine Community College. I'm making this video for my print reading class for this fall, and I'm doing it for two reasons. One is I want to give you a sense of what our classes will be like when they start up in a couple of weeks. I do plan to use Zoom, and I do plan to have what I call synchronous classes. We'll meet together once a week for a 2-hour block, broken up into two 1-hour pieces with a 10-minute break in between. And then I'll have another 2-hour block later in the week where I will start a Zoom meeting, and then you'll be free to join and ask questions or anything you want to do. But you're not going to be required to attend that, and I won't be doing specific presentations. Instead, I'll be asking questions of people. So the other reason I'm doing this is because I want to just explain to you some fundamental things about print reading that are going to be reinforced. And I'm going to do it in the form of a basic lesson on conversions. That'll give you a sense of how the teaching process goes, but it'll also reinforce some things that I'm going to be saying over and over again this semester. I will say this. I teach all kinds of classes, and I have for a long time, and I teach our most advanced classes as well as all the other classes that we teach for the most part. I think the most important class I teach is this one, because I think it's really critical that you end up with some really fundamental skills in technical communication if you're going to go into any technical field. Having said that, I'm just going to get started. So before I get on the camera I'll be using to do the demos, I have a monitor over here on my left. I'll be looking at it once in a while. So what you'll do is you'll see me looking over here. I also have a monitor right there, and occasionally you'll see me looking at that monitor as well. And I'm going to have a piece of paper over here, and I'm going to be looking down on that piece of paper while I sketch, do calculations, and make comments while I'm doing it. Also on my screen, you'll be seeing what I'm doing, and you'll also see a calculator for right now that I'll be using periodically as well. Sometimes I'll use the other monitor because I'll be demonstrating things with 3D models, for instance, and we'll be talking about orthographic projection. But we're going to have several different things going on at the same time. So I'm going to now share my screen. And to share the screen, I just have to go over here and pick the screen I want to share. And right now you're looking at a sheet of paper and a pencil and a calculator. So what I'm going to do is go through a basic lesson on conversions. And I'm going to start with something really simple. And I'm going to use that as an example of the strategies that I want you to apply when you do any conversions at all in this entire class. In fact, let's just go all the way to the end when you graduate. And these strategies I developed over a long period of time of working in a great number of technical jobs. I've been teaching here for 32 years, and I've taught other places before that. But I also had the great joy of having a number of other jobs, including working in a sheet metal shop, working in a machine shop. I've done carpentry work before. I was a maintenance mechanic in a chemical factory. Spent a year as an oil rig roughneck. Believe it or not, all those jobs required that I be able to come up with accurate values and do them with some precision and some confidence. The things that I always did to help myself make sure that I reduced the likelihood of error as much as possible are really three things. One is I always guessed in advance as to what the outcome should be. I knew going into a calculation generally what the results are going to be. Pull up to a gas pump, you fill your car with gas, you get in and you say, I'm going to calculate my mileage. You got a sense in your head your mileage is going to be 25, 26 miles per gallon, which means if you do the math and you get it wrong and then you find out you've got 1,500 miles to the gallon, you know you've made a mistake and you go back and you fix it. The other thing I've always done is written down the units that I'm actually using for my math every single time, and you're going to have to do that for everything you turn into me. I am going to have to see units with all the values. Otherwise, those are going to be incorrect, and you're going to be asked to redo the work. So as you go through this, you're going to put all the steps down when you do the conversions and other kinds of math we're doing. You're going to write the units down. And as you do that, you're going to cross units out where they get crossed out, and they're going to be crossed out because you'll be canceling them. The third thing is that you're going to be dealing with values where you need to decide on a precision sometimes. For this class, I'm going to have you do all your math to 4 decimal places of precision, unless I ask you to do something that's different. And that's only when we're dealing with decimals. We will be dealing with fractions as well. Fractions are significant in architectural. They're not so significant in any other discipline. So we're looking at a piece of paper here. The first thing I'm going to do before I even get started, I'm just going to put a little X on that sheet of paper, and I'm going to get it under my camera. And in the camera, I'm going to say to the camera, focus on that X. It's going to do an automatic focus so you can see this as easily as possible. And now, since I don't want that anymore, let me just erase it. Okay, now, it didn't erase very well. That looks a little better. Okay, now we're going to deal with conversions, and I'm going to start, because I'm just showing you basically a process. I'm going to start with something you know. There are 12 inches in every foot. Now I say you know that. You know that if you grew up in the United States or Burma or Liberia, but if you grew up someplace else, you may not be familiar with even that piece of information. But it's important that you know that there are 12 inches in a foot. That is a conversion factor. The factor itself is the number 12. But a conversion factor is not a conversion factor unless there are units associated with it. So that 12 means that there are 12 inches per foot, and that's how we're going to read this. Now, when you do a conversion of some kind, you start by saying, hey, I've got something in feet. I want to know how many inches is represented by that same distance. In this case, we're going to say 8 feet. We write down 8 with the units, which are feet. And before I put down any kind of operation, which would be a division or a multiplication operation, I'm going to write the conversion factor, 12 inches per foot. Now, I'm either going to multiply that 12 by the 8, or I'm going to divide 12 into 8. If I look over here, 8 feet converting to inches, if there's 12 inches in every foot, I'm looking for a much bigger number than 8. If I look over here, dividing is not going to give me a bigger number. Multiplying is. I also now am going to go and look at my units. I have feet times inches per foot. That means from a division point of view, the feet could be down here. Feet and feet cancel out, leaving me with inches. I do the math, and I have 96 inches left over. I've canceled out the feet. Inches are left. 96 seems logical if I take a look at it. That's the conversion factor. Now I'm going to give you a little warning. If you go online and you look for conversion factors, you frequently find conversion factors online that are inaccurate. And here's why they're inaccurate. Suppose I wanted to have a conversion factor for how many feet are there per inch. I know there's 12 inches per foot. Well, how many feet are there in 1 inch? It's going to be a decimal value. It's going to be smaller than 1. And the way I would find that out is I would say, let's divide 1 by 12 inches per foot. And that is going to give me 1 divided by 12 equals 0.083333, and 3's all the way down. It's also going to invert those units. So I could write 0.08, and a lot of people would stop right there and say, well, that's how many feet there are in 1 inch, 0.08. Well, that's not true, because we've gotten rid of all those other values. It'd be more accurate to say 0.0833 feet per inch. However, they are not equal because we have rounded the value. That is not an exact and precise value. My point is this: don't use a number like that. Even if you find that online, that is not an accurate number. The accurate number is the one you know, 12 inches per foot. You're always going to use that. Well, you're probably thinking, well, all right, I can convert from 8 feet to inches by multiplying times 12 inches per foot. What if I'm going the other way? Well, if we're going the other way and we start by knowing we have 96 inches and we'd like to know how many feet are represented by 96 inches, we'll start by writing down the value we're converting, 96 inches. I'll leave a little space. I'll put the 12 inches per foot. And now, what do I put there? Am I multiplying or dividing? I'm looking for a number smaller than 96. The only way to get that is to divide the 12 into the 96. So I am, in fact, dividing. I could write that 96 inches over, 12 inches per foot. Either one is correct. I could write that either way. So what I now have is inches divided into inches cancels each other out. When you have something in a denominator below another denominator, that moves up here. 12 goes into 96 8 times. I'm left with 8 feet. Same conversion factor. Going one way you multiply, going the other way you divide, period. Don't ever do the math and then use 0.08 or 0.083 or even 0.0833333. Use 12 instead. That's how conversion factors work. Now let's apply it to a few other things that you may or may not know. I have another conversion factor for you. There are 25.4 millimeters in every inch. That's the definition of an inch. Inches are legally defined in the United States as being 25.4 millimeters long. Now, that's the conversion factor. What you will find online frequently is they'll tell you, oh, well, there's also 0.04 inches per millimeter, which is not true. And it's not true because it is a rounded value. So let's see why they came up with that. They say, well, we're going to go the other way. So let's take 1 and divide 1 by 25.4 millimeters per inch. And that will give us an inches per millimeter value. Divide 1 by 25.4 and you get not 0.04, you get 0.03937, and it keeps going. The only way to come up with 0.04 is to round everything up to 0.04, and now you have what's known as a rounding error. And rounding errors are the reason why things don't work sometimes. It's why Mars landing modules don't hit the it's actually not the reason in that case. That was a metric and inch problem. But it's the reason why things don't work out when you're measuring things, where your windows are in the wrong place, where you don't have enough concrete. So what we want to do is always use an exact conversion factor. In this case, that's only 25.4. It is never 0.04, no matter what it says on the internet. So let's try to use this now. Let's say I have 1200 millimeters. That 1200 millimeters is a logical dimension of some architectural drawings might have a dimension like that. I want to know how many inches that represents. If I want to know how many inches that represents, I'll write down 1200 millimeters and then 25.4 millimeters per inch. It's going to be my conversion factor. Am I multiplying or am I dividing? Well, if I multiply, I'll have millimeters times millimeters, which is millimeters squared, over inches. That's not what I want. I want to be left with inches. And the only way to do that is to divide this into this. So I'm going to have a big division symbol here. So the millimeters goes away. 25.4 gets divided into 1200 divided by 25.4 equals. And now I have a value of 47.244. And I told you I want 4 decimal places. Since I want 4 decimal places, I want to do something with that 4th decimal place. The 4th decimal place in this case is 0, but if you look directly to the right of that, if that value right there, the one to the right of the precision you want, if that value is 5 or greater, you need to raise this by 1 digit. In other words, you're rounding up from here. So I'm going to put a 1 there. Now, what are my units? Well, I'm left with inches here. So 1200 millimeters is 47.2441 inches, a little under 4 feet. Now, that's a rounded value. It's rounded to 4 decimal places, so that's probably good enough. In some cases, I might want to round that to another, maybe a 5th decimal place, and in some cases, it might be close enough if I round to 47. For my purposes, you're going to round everything to 4 decimal places unless I indicate otherwise. Let's go the other way now. Let's take my height. I am 6 feet 2 inches tall. 6 feet 2 inches, and I want to find out how many millimeters tall I am. I know that it's 25.4 millimeters per inch. I'm going to do something with that 6 feet 2, but even though we write 6 feet and 2 as separate values, we can't calculate them as separate values. We need to put them together into one number, either inches or feet. We're going to start by putting them together into inches. So before I do this calculation to go to millimeters, I'm first going to go over and say 6 feet times 12 inches per foot, the feet cancel out, equals 72 inches. So the 6 foot part of my 6 foot 2 inch height is 72 inches. Plus I have another 2 inches. So I add that 2 inches in. Now I am 74 inches tall. Knowing I'm 74 inches tall means I can come over and say 74 inches, 25.4 millimeters per inch. Am I going to multiply or divide? Well, again, if I look at this, inches are already below the line in my divisor. I'm going to multiply or divide. If I multiply, inches cancel each other out. So that's what I'm going to do. And I'm going to end up with a much bigger number because they're 25.4 millimeters in an inch. We'll clear this out. 74 inches times 25.4 equals exactly 1,879.6 millimeters. That's how tall I am in millimeters. By the way, we don't put commas in numbers when we're doing technical math. Commas and numbers are helpful when you're dealing with things like money, and they actually could be helpful in other situations as well. The problem is in every other country, or most other countries that are on the metric system, a comma actually means a decimal point. So it causes some confusion. So we're just going to leave the commas out. Now, that's how tall I am in millimeters. So I'm going to do a different kind of conversion now. I'm going to go back and say, all right, I'm 6 feet 2 inches. There's a conversion between feet and meters. It's also a legal definition of a measurement in the US. A foot is defined legally as 0.3048 meters. So my conversion factor is 0.3048 meters per foot. Every foot is 0.3048 meters, not approximately, exactly. Once again, you could do a division over here of 0.3048 meters per foot to get how many feet per meters, but it would be a rounded value, and you should never ever use it, no matter what it says on the internet. You know, this whole thing about the internet, people tend to think if they look something up on the internet, it's got to be true. And here's a great example for how that is not always the case. You can look things up on the internet and have it say things like, you know, 0.04 inches in a millimeter, and that is just not true. Now, let's go back to this. In order for me to use that conversion factor, that number, 6 feet 2 inches, I have to have that in feet. Before it was easy, I just turned the feet into inches and added 2. Now what I need to know is how many feet are represented by 2 inches. That would be 2/12 of a foot. How do I know? Because 2 inches, 12 inches per foot, multiply or divide. We're going to divide in this case. Inches go away. Inches go away. Feet come up. 2 divided by 12. 0.1666, and it goes on forever. So we just finally turn it into a 7. So that's going to equal 0.166. We'll call that a 7 feet. That's what we have left over. Crossed out the inches, we end up with feet. We have 6 feet plus 0.1665 feet. So we add our 6 feet in there. And now my height, decimal height in feet, is 6.1667 feet. Now I'm going to do the conversion into meters. How many meters am I? First, I'm going to come over here and say, you know, as long as I'm using a calculator anyway, I'm just going to leave the actual precision of the calculator, which is 14 decimal places, instead of retyping in the 6.1667. I'm going to do that by just adding the 6 back in here. So there, right there, to a great level of precision, is my height in decimal feet. Now, how do I convert that? 0.3048 meters per foot. I'm going to multiply that or divide it. What am I looking for? Well, there are fewer meters in my height than feet, because a meter is a little more than 3 feet. So I need a smaller number, which I can only get by multiplying those two together. And if I multiply them together, feet cancel out and I'm left with meters. So now I take this value and I'm going to multiply it times 0.3048 meters per foot, and it tells me that I am 1.8796 meters tall. Now we're going to look back up here where I calculated, oops, I'm sorry, I have been drawing off the screen. I just realized that. If this would have happened during a Zoom class, one of you or all of you are going to unmute yourself and you're going to say, Dan, we can't see what you're doing. And then I'm going to move it up a little bit. I'm not sure how much of that we missed, but I'm going to leave it this way, just as an example of what I expect from you if there's something that I'm doing that you don't quite understand. Now, I want to point something out. I am 1,879.6 millimeters, and I'm 1.8796 meters. Those two numbers look very, very much the same, except for the decimal places. Well, let's convert this into millimeters. Here's another conversion factor for you. 1,000 millimeters per meter. I'm going to convert these two. In order for that to cross out, for meters to divide into meters and cross out, I need to multiply. Multiplying 1,000 times that gives me 1879.6 millimeters, which is the same thing I got up here, which makes sense because even though I used different conversion factors, one for meters to feet and one for millimeters to inches, they're exact conversion factors and they must end up with the same results. Now that's an example of how we're going to go about this class, and it's also reinforces some things I want you to be reinforced. At this point in a presentation, and probably a little sooner than this, I would have said, all right, I'm going to stop sharing my screen. I would then look at my screen where you will all be arrayed, all of your little images. You'll have your photos, your video on, which I hope you will, so I can see what you look like and see you and kind of get a sense of how you're understanding things. Or there'll be your name. Some of you may not have a camera. Some of you may just not like being on camera, but I'm hoping that all of you will be on video. It just makes it easier for me. Normally in a classroom, when I'm doing a presentation, I can look around and I can see people on occasion and go, like that. I know that person did not understand what I just said. As a teacher, that allows me to go back and make sure I can clarify it. On Zoom, I don't have that option. I just can't keep track of all the individual faces on my screen. And I can't see them well enough to be able to get those kinds of cues. So periodically, I'm going to stop and say to each one of you, Olivia, did you understand what I just said? What I just presented? And Olivia is going to either say, no, I didn't. I just didn't get that at all. Could you just please go back and do it again? Or she's going to say, yeah, I'm wave, or she's going to give me a thumbs up, or she's going to turn her audio on and say something. Or if you don't have your video on, at the bottom of the Zoom screen, you're going to see a bunch of little icons, little buttons, and one of them is called reactions. And if you look at my screen right now, if I really understood, I do that, I get a little thumbs up. So there's a way for you to tell me that, yeah, I'm good, you can keep going. At that point is when I expect people to ask questions. You're going to have to make an attempt to break through your shyness and ask a question if something doesn't make sense, because I'm simply not going to be as good as I normally am at sensing when things don't make sense. Listen, I'm looking forward to this class. I wish we were going to be in a classroom. I would much, much rather be in a classroom with you. But we know, it is what it is, as they say. You're going to learn this. I had a chance in the second half of last semester. All of my classes went online. They were all Zoom classes. A little bit of trouble some people had making the transition, but when it came right down to it, people learned just as much when we get done as they had been learning before. And the classes, the end result of the classes for the people who finished were the same kinds of results I normally get. And that means that people all ended up leaving understanding how to do the fundamental things I'm wanting them to do. So look forward to the fall. We'll see you then. And now what I'm going to do is end the meeting,